Hello, everyone. Thank you very much for the introduction. My name is Lucian Gruia. My role here at Ciklum I'm working for about 6 years at Ciklum. My recent role is head of data science and AI. And today we are going to discuss about building these AI agents. But as we are in a dev talk event, we of course are discussing from the developer perspective. So we are looking to architecture, and we are looking also to the one of the most common, most like hyped protocols today, MCP and A2A, right? So first thing first, let's understand what are AI agents actually, right? I can give you some formal definitions as well that actually nobody really agrees on them. First of all, when we think of agents, we have the tendency of presumably they are entities that have a bit of consciousness. That's why also a lot of people and organizations are making sometimes confusion between intelligence and consciousness. But in fact, AI agents, if you gather like all the definitions you would find across the internet, you will see that mostly the most commonly agreed term is that they are entities that are autonomously perceive their environment and they are able to take decisions, right? Then, based on those decisions, they take some actions, and they do all this just because they need it ultimately to achieve some goals, right? So the difference basically between a traditional application and AI agent is that they do not know actually the final goal, right? They make decisions along the way, right? Now, if we are to build these agents, we need to follow, of course, some design patterns, which gives us the agentic architecture. This, this agentic architecture basically means a design paradigm, a new design paradigm. It's, of course, goal-oriented, as in traditional architecture, but what we are going to explore today is how we build this architecture by following the best practices as we know them today in 2025. Of course, these are evolving. If we have to discuss about this last year in 2024 or 2023, things would have been probably differently. But as of today, we know few design patterns. We know we have some protocols, and of course some applications that are emergent. They did not simply exist as use cases a few years ago only. Going further, we are addressing and we are analyzing what is actually where is actually the leap. Where does the traditional software development in applications is changing, is shifting towards AI agents? Of course, we are talking about some keywords such as autonomy, such as environment interaction or goal orientation, but without real life applications, these are more like just academic and theoretical concepts. So we will need to see what autonomy actually means in terms of agentic AI. Now, let me give you first also a plain English explanation on what agents are. So imagine we have a self-driving car that sees the road and decides whether to stop or they need to turn or adjust the route along the way just to reach the destination. What's happening along the way is that the road is usually predefined. The self-driving car may know what is the best route, but sometimes things are happening which are so much unpredictable that they have to take decisions and compromises so that they will still reach the destination. So this would be an AI agent. Now, the separation between an AI agent like this and the sub-agents that is building the big self-driving AI agent car, it's not that clear anyway. I mean, no one really agrees on where exactly is this limits, because we can consider the self-driving car itself an agent as well as its own components. We may have like an AI agent that handles the visuals. We may have an AI agent that handles the temperature of the engine and so on, right? As well as in biology, like human body, for instance, right? All the components of our body are part of us, but if we exclude all of them, who we are, right? We are still the sum of them. So that's the same principle with AI agents. Now, in terms of plain English explanation of translation of agentic architecture, think of a team of working together. And I believe this is the most applied example I can give to you, and we are going to discuss later today in a short demo. If we are a team of developers, basically we are writing code, but in order to write code, we need to analyze the requirements. In order to analyze the requirements, we need basically to split them into smaller tasks, and then by applying a divide and impera principle, we are basically splitting tasks in smaller tasks and implementing each other, right? In this case, we are acting as a team of agents. We are coordinating each other. Everyone within the software development team is an agent, but that doesn't mean all these agents should be human agents, right? They can also be AI agents. So we'll explore today how AI agents can work together alongside with human teams. First, let's start with a real life example, something that most of you probably work, like a platform that has a common architecture. It's like a real-time booking. Even if you did not work on building anything like that, at least you experienced interaction with a booking platform because you probably either bought something from the internet or just booked an event, a ticket for an event, right? So usually how would you do that? You have a web GUI, then this web GUI it's calling a REST API. The REST API is hosted on a web server, which has a relational database, like link to that server. They might be hosted or not on the same infrastructure, but further they are linked to a notification application which circles back and send at the same time or even less notifications and inform the user if or confirm the user if their action is validated or not. In the web GUI, of course, the user will see this response. But in order to communicate later with the user, maybe after the user close the browser window, we can go back, for instance, and send an SMS, right, to them. This is a traditional application, which basically involves several steps and several architectural layers, right? What is the problem with this traditional approach? I mean, not necessarily the problem, but the limitations. The limitations are that we always need to make sure we are designing the web GUI in a way that all our users will understand them. So then that means also that our application it's limited from the user perspective. It's limited to the GUI capabilities, right? Because if our GUI cannot offer more features than we present, then the users will not be able to extract more from our application. And of course, that's impacting the user's creativity. On the other hand, it's preventing them on doing forbidden actions, right? Now, if we switch from this approach to an agentic approach, what we will notice is that we can replace that GUI with a chat application, with a chat GUI, which discuss with an AI agent, which basically bridges the whole interaction between the user and the web server, including the response. What does that mean? It means that basically the user is not limited anymore on the GUI features on one hand. On the other hand, it means that our user basically can ask anything, including forbidden actions, right? On the other hand, we don't need to constrain users and we don't need to invest that much in building the front-end GUI, because the chat application basically enables the users to interact with us in natural languages they would interact with humans. So then the focus and the complexity of our system shifts from designing multiple sub-components of our app to designing a single one, but which needs to handle a more complex cognitive, complex request or activity. Now, This comes, of course, with new challenges because let's say we are not talking necessarily about performance or about scalability, but about security and about cognitive complexity, because at some points we need to still guardrail somehow the interaction with the chat with the chat application, so that user still should be limited to addressing some forbidden activities, right? They cannot simply ask us to delete the user base from the database, right? We still need to prevent that. But on the other hand, we need to give them as many possibilities, some of them that we even us as application architects or designers excluded from the beginning or did not think of these capabilities. The chat app does that. So that's probably one of the shifts that will happen because of agentic approach. And this agentic approach behind the hood, they are actually more or less traditional applications that actually do more or less LLM calls, right? Or they are using some embedding, some embedding stored in the vector database to detect similarities, and they can act more or less like a RAG, right? I'm using more or less because you will see at some point why I also like emphasize this as green. This AI agent, it's because this actually looks like a black box at this point, right? We don't know what's there, but on the other hand, we don't should not expect this is something totally new. It's still a mobile app, or it's still an application that has still respects the traditional constraints or traditional design patterns of building an application. But what's particular to it is that the communication should be also handled in natural language, which is biased, which offers us more space for interpretation, and that makes this cognitive complexity actually much more higher. It's not that robust and rigorous as in traditional logic. So let's see what's here inside the box, inside this agent actually, right? Because the agent should now carry the whole burden that comes from the chat application. And also the chatbots, in this case, is not just a conversational app, like let's say ChatGPT, where we go and ask questions. It's actually from something, it's actually an app from which we expect some actions, right? So it acts both as a knowledge engine on one hand, but also it's an actuator, because we can ask it to do a reservation for us. How do we do that? Through the agent. But how does the agent connect to the web server and to the database? Through some protocols, right? That's where we are going towards. It's these protocols are the communication patterns that we agreed on, mostly A2A and MCP for today's talk. Let's see some of the design patterns. So let's see what's inside that box, inside that AI agent green box, right? There are also some submodules, of course, right? But these submodules may have different roles, and they may act differently. They may be reflection engines, or they might be planning engines, or they might be cross species, right? Because as I mentioned earlier, in a self-driving car, the car itself, of course, it's not atomic. It has subcomponents, and those subcomponents should talk to each other, right? So we have the option either to design a big agent that handles everything, or to design our agent as a structure of multiple sub-agents, and each of these is specialized on some specific very small task. But that small task, it's never actually atomic, right? It can be also split. And where do we do the split? Here is an art. It's actually the architectural decision, and every use case should have this architectural decision. There is no one size fit all response in this regard. There are only these patterns that we can use, right? Like some approaches, let's call them, right? We can either use some tools such as, and I'm still referring to both use cases, to the self-driving car and to the booking app, right? If we are talking about the self-driving car, a tool used might be honing, right? If we are talking about the booking app, a tool used might be call the database and book this spot for me, right? Let's see how these patterns look like actually. So these patterns, basically, they are logical structures, right? Which can be, from now on, you look at the diagram and you can start implementing the code, basically, right? We have the user that does the request, and the request goes to a module, to a method that is a responder. That method provides a response, and it's our job. It can be like even a default string response, or it can be something that's augmented by an LLM, but it's a response, right? Further, further that response is passed to another module that we call executor. What does the executor do? It's actually attempting, or if we allow it, right? It's conditional, but it's actually attempting to do an action. But that action or that response, that action it's the response itself, should go to another responder, which this times we call it revisor, because the role of the revisor is not to provide a response, it's just to make sure that the response, the initial response here, is aligned with this user interface, with this user request coming from the user interface, right? So the revisor basically will look at the initial response, will improve it to some extent, and then we'll go back to the executor in a loop until we decide, yeah, the revised response it's good enough, right? What are the use cases for this pattern? Think about designing digital avatars, or think about writing some articles, right? Let's take the first example. When you design a digital avatar, basically you have an image that should move, right? I have my hand here and my face, they are both moving. What I'm actually doing is basically editing the image frame by frame, but I need to make sure the next frame is consistent with the previous one, and the next one the same, and they all have a logic within that chain. Same as for writing articles. You need to make sure that the article, even if it's longer, is still not out of context. That's why you need to build it parts by parts, and then make sure those parts are interconnected and they make sense together, they flow naturally, and so on, right? This is one of the reflection pattern. And now I'll pause here a bit. I'll pause the slides actually, and we'll go and show you some code, right? So from this point, we are going to look in both IDE and slides, so we can understand how these patterns are actually looking like in real life, right? So we have, for instance, the method respond here within our AI agent. What does it do? The method respond basically is assessing our interaction between the user, as I mentioned earlier, and our core agent, right? Then it's assessing and it's checking if it's a command, if it's a knowledge update, if it's a Git, Jira request, and so on. But at some point, it goes here to the handle conversation. If it's not any of them, it goes to the handle conversation. The handle conversation method includes this initial response, which comes from this generate answer. We'll see later how this generate answer method looks like. But the initial response basically comes from here, from this generate answer method. This again can be like even an empty string or a hello world or a default string, default response. It is linked, as you see, to our knowledge base, of course, and it's also related to the user input, but still it's an answer. It's an initial answer. So here we have the computing effort actually on generating this response. While after we have that response, if this behavior enforcement flag is turned on, it's active, then we need to go and do the reflection basically, right? And this reflection can go in a loop, right? It can be a for or a while with some pre or post conditions, right? In my case here, just for the smoother demo, it's just a simple condition that checks the behavior enforcement. It's turned on, and if it's turned on, then it's sending this request to an LLM, with the initial response by asking the LLM to refine our initial response without any logic, without any relation to the user input, just asking it how that initial response is actually connected to the behavior that we want to enforce. In other words, it's basically reflecting on its own answer. The reflection might be including the validation of the answer on one hand. On the other hand, it might be related to the styling. So this behavioral setup basically takes us to a behavior settings, which looks like this, right? We may have response length, we may have personality, response style, and so on, right? So this is one way on how we can, let me go back to this one. We can do this reflection. And after we did that, of course, we are recording the interaction and responding with the agent response. Now, another pattern is tool use. What does it mean, tool use? Tool use means basically we send a request to our LLM. The LLM thinks about that. So when we had that generate answer method, you saw that I'm actually asking an LLM further. But then the LLM in the first place should take a decision which is the tool that we're actually using, right? And this decision could be made actually by an LLM or by some predefined rules and conditions in our application. After we take the decision, we select the tool and we call that tool. If we don't have any to use any tool, of course, this loop is ending. But if we are selecting a specific tool, we are calling it and we take its answer and pull it into the LLM. How does it look like into code? Let's go back here to handle conversation. I'm sorry for this. I'm a bit cold and my throat is hurting a bit. So we're going back here in this respond method. Basically, we have the user input and we need to choose a tool. Here I have some branches, such as if is this Git related, yeah, process it with a Git request. If it's Jira related, process it with Jira, right? I could basically cover both of them into another method that does exactly this. Select my tool, right? Tool selector, selects tool, right? This method. I listed them both here, and let's see how does the logic work, because the logic can be pretty plain and simple, such as command detect, right? Command detect it's another tool, it's another logic that we can call, which is just a helper method. It's command, and how does it look like? It's checking if it has this double slash within the text. So that's it, right? Is command. But further, we can do a reasoning is command prompt. And this reasoning is basically calling an LLM. Same as for Git branch or for Jira branch of the logic. Let's verify, for instance, if our request is related to Git, right? So how does this method look like? It looks like this. Return one if user request is about Git, GitHub, or branches commit, anything like that. Or return zero otherwise, right? So this is Git related method. Basically, it's just a prompt that is further sent to an LLM. You see this method, LLM ask, is basically sending our prompt that we built here. So that's pretty much all. So the tool selector basically means that we are using one way or another, more or less LLMs, right? We can simply just add some regular rules there, and we can do these calls, and we can actually validate these decisions with an LLM or not, right? Use cases for this, RAG, of course, is one of the most common. But also imagine you have a weather forecast, right? When you need to decide whether if you are in a location or another location, then you may choose an API or another API for North America, for Africa, for Eastern Europe, and so on, right? Sometimes we need in our logic, and we couldn't do that before, we need to embed we need to engage some LLM so they can help us with the decision. Otherwise, I cannot I cannot understand if user prompt it's related to updating the code or relating to any Git request unless they have some keywords. But it might not be the case, right? It might be simply an indirect request. So then an LLM would understand that in the same way as a human would understand that, right? Now, planning is one of the most common and important patterns because initially we send a request to the LLM within our application, but this app might have multiple branches within the logic and may have multiple sub steps that are being executed. Some of them in parallel, other sequential, right? But we need someone to reason that and to do the planning. And traditionally, how would we do that? We would hard code a lot of workflows, right? Not hard code, but configure, let's say, right? Or not configure, but read them from external logic provider, workflow design provider, right? Now, in our case now, this can be also helped by engaging an LLM because an LLM could be tasked to do a plan and select task by task and plan them in order. They can be this plan can be wrapped into a reflection pattern and we can validate it. And at the end we can engage the agent, which is agent itself could be a tool or not, right? Could be considered a tool as well. But I represented it as an agent because this agent further can have tool call and so on, right? Now I'm not insisting further. I think you got the idea, and the logic flows the same within the code. Further, actually, what I want to emphasize is that all these patterns, all these sub-agents could be interconnected in some ways, right? They can have a supervisor, they can have can be connected into a network, can validate each other. They can work hierarchically, right? Like a human team. Even in human team, this hierarchy is not always clear. So the same way we design this within agentic architecture, and each box here is basically another sub-agent that has some implemented some patterns. It might be one or more that are being interconnected. So this basically the use cases for this might be smart home automation ecosystem, right? In this case, you basically have a supervisor or a network pattern most often when you have multiple agents that are interacting with each other and take decisions, which you don't need necessarily to design on yourself. You can just instruct the agent go in economy on power saving, and then they will decide whether if it's you are not home or you are home or not, whether if you have more people in the house or not, whether if the sound based on the sound or of CO2 sensors, they might decide whether you are sleeping or not, and a lot of things like this, which might adjust the temperature and might adjust the energy consumption. So this will go towards a power saving scenario, right? As well as I mentioned earlier, the multi-agent collaboration could be also looking something like a organization, human organization. And this is the example that I want to show you as well. We can design basically a CEO, we can design basically a CTO, a programmer agent, and each of them are specialized, or they can all they can all actually be combined under the same umbrella, and that chat interface could help us either acting as one or the other, or acting as an unified application, depending on who is talking to the interface, right? Cross-species agents is the last pattern that I want to talk about. These cross-species agents are basically agents that, I mean, so far you've seen agents that are talking to other agents because they are in the same code base, in the same module, and their interfaces are actually just some methods calls, right? So here I have the agent that responds to questions, but then I have another reasoning agent that is checking whether if this is a prompt, whether this prompt is a command or not. If I go here and I'm checking how the method looks like, it's basically another classifier. It's still another prompt, right? But this is an agent itself. This method is an agent itself, or a sub-agent if you like it, right? This agent basically it's invoked here within this condition, and it's part of the respond method, which is actually the orchestrator, right? Now, when we want to go outside and make this agent talk to other agents, we don't know actually what are the methods, because here we have the method prototype, right? We know what are the arguments that the method accept, what are the parameters, right? We know how to pass these parameters, but sometimes we simply don't know how to integrate with an external agent that is being designed by someone else. And in that case, let me show you how an interface may look like. Fast API routes. Here we have A2A interface. So A2A interface is basically acting like a REST endpoint, right? But each module, it's presenting a capability board, right? It's presenting its capabilities. Let's see how that actually looks in if we call this endpoint A2A info. So it looks, maybe I can expand this a bit, right? I can call this agent's A2A interface, and I can see that the agent is called Ciklum Agentic Framework. It's version 1. It has specific capabilities, such as one of the capabilities or skill is chat. And this is the description of it, right? And so on. Basically, this is a REST response. It's pretty traditional, you may say. But what's important is that we can process this with another agent that is looking for capabilities. Now, we don't know how that capability, there is no standard, and it's very hard to standardize that, how a capability of talking to another agent or to a human agent may look like. We may call it chat, right? But um, another service provider may expect something like talk, or may expect something like speak, right? Or may expect interaction, whatever, NLP interaction. So we cannot do that. Actually, we cannot predefine all of this. But what we can do is actually to process these responses with an LLM and expect that LLM will understand that this chat here, okay, it maps to one of our method, which further has its own implementation. But what we actually, the only thing that we need to do is to run our implementation as it is, but just transform the output as the other agent expects, like input string. That's all it needs, right? It has one or two parameters, for instance, right? So our LLM would be able to do this response and adapt to capabilities that are presented by the other agent. This agent can even talk to itself, because I can address a question. And then this question could be um, addressed to its own endpoint, right? Now, going back here to the use cases, let me see what is our approach in this regard. So in our approach on designing agentic architecture is having an agent core, which has multiple sub agents such as topic manager, reflection agent, tools calling agent, and here having a data source that basically ingests data from different platforms. This data is ingested, and then further it is passed to Agentic Core, which decides whether to call some tools or not, right? This might look a bit complex, but actually, in fact, each of these square is another pattern, another subsquares, and so on, and it goes deeper as I explained earlier. Now, let me see an example on why this is important. Why do we want to design an agent like this that has a conversational GUI, right? And I'll stop presenting this, and let's open this chat interface, right? This is our agent. We call it Ciklum Prodigy, and basically what we want is that to have some action as well, not only to respond on some actions. And I will say please help me document the last discussion we had in our team's call transcription, right? So what does it do? Basically, let's imagine we had this discussion here. It was transcribed. One sec. I need to open this actually with Notepad. Okay, so this is the transcription, right? We have some transcription here, and what we need to do is to create some of the Confluence pages here, or we need to create some Jira tickets, right? Based on the transcription. So how does it work? Help me based on the last. One sec, I have some scripts as well, so it will work faster. I'm not typing everything. Okay, so I will ask again. Now it's asking me to share the transcription, right? And then let's ask. I'm asking it to create me a Confluence page based on this transcription, and then asking to split this into Jira tasks, right? That it's basically the response from our brainstorming session. So here, what I got is the ideas from the last call, which is formatted like in MD as MD file as the agent responded, right? So we have decision made during the transcript, action made, owners, open questions, and so on. Further, we are asking to create a Jira ticket out of it, and it should be somewhere here, 42 probably. Yes, it's 42. Compile Black Friday incident, right? So we have a description of this. Further, we can even go and say, great, I would like to implement that in my code base, right? Implementing this in the code base, what does it mean? It triggers now another agent, another coding agent, and I'm using open code headless here in order to interact to interact with my chatbot to the and send the instruction to the coding agent. What does it mean? Okay, I'll let this work here. It will take a while. We can look to we can look here. This is the code base where it's writing the code. But if we look in the code, how does that look like actually, the interaction with open code? So basically, we have in our agent AI, we have a branch to decide whether if we want to write the code or not in this open code branch, right? We are deciding whether if the request is related to open code. Actually, if we want to trigger an actuator, if we want to do a call, a tool use, and then we ask the open code to handle it. How does it handle it? It is deciding, right, if it's the case to write the code, it's doing the plan, right? Then it's creating the session, it's checking if the session exists or not, and so on. And ultimately sending the message to open code. How does that send the message? It's an A2A or an API, REST API, right? How does it pull the data from Confluence? Going back here, we have Confluence branch, which also has its own handle method. So in Confluence, if you look here, I implemented both protocols. So we have, first of all, we have the Confluence API, which basically has some methods such as create page or such as add labels, add estimates for Jira actually, right? Or execute some CQLs. And ultimately it has this get and post method that are basically reading or writing Confluence pages, or we have the MCP implementation, which MCP is basically the version offered by Atlassian, and we are just calling those methods like create page, right, or create page with context. And what does it mean? The context goes and circles through across other pages and make sure they are aligned, right? Let's go back to our coding agent and let's see. It's still working, so this may take a while. It depends on the request, right? It also lacking some API keys. So what happens? It's basically it's switching to another LLM if it's lacking this one. Maybe I could ask building something much easier, such as a Hello World or Hello World guy. Oh, actually, we have BFF fixed in Go. We got the answer. It's still writing some code, but it's implemented for us. It wrote this package in Go, right? Which is related to our campaign. It's checking the BF 2025 global banner fix, right? And if we look in the transcript, we'll see that people were discussing about it somewhere here, right? The campaign ID was BF 2025 global and so on. So people were discussing about this during the team was discussing during the team's call. It was transcribed, then it was documented within a Confluence page. Here we still have this ID. It was then split into multiple subtasks in Jira, and then our agent had the context awareness and handled the whole chain of communication with some deflection patterns, as you saw earlier in the code, with some tool use, some decisions, and went to this code repository and created me this BFF fix Go. That's just based on the existing code base, right? Which of course implemented that. Yeah. Okay. So with that being said, I think we can go back to draw some conclusions. First of all, I would like to look into how the LLM inference looks like, because during this we don't during this all these operations we don't need to use a single LLM. We can go using multiples, even cloud-based LLMs or local open source LLMs, so that we are distributing the for them computing power. And an architecture that would probably be applicable within an organization would be connecting documentation part, the coding part, the backlog part within a single agentic fleet, as we like to call it, which means basically it's either a big agent with some smaller agents or multiple agents. It's up to you, depending on how you want to call and define your architecture and you want to run them. So call to actions. It estimated by Gartner that in 2026, 40% of enterprise application will use AI agents. So that means most of the tech leaders basically have 3 to 6 months to define the strategy and decide their architecture and adapt that. Of course, what's important is to still focus on people and culture, because the culture is shifting probably due to rise of Gen AI. And I heard the previous question about LLM and how does that affect the people and culture. I believe people basically will start working more and more like with AI agents like assistants, and they will be like will have a place on our table on collaborating with us.